Hello everyone, we are back with another Leetcode problem. Problem 253. This is meeting room, the second one. So the problem statement says you are given an array of meeting time intervals. So this is the interval problem, where each interval looks like a couple of values, the start time of the meeting and the end time of the meeting. So this is one meeting. So we are given multiple of them. That means we are given an array of them. As you can see here, we're given 3 meetings. Each meeting has a start time and an end time. Start time, end time, start time, end time. Okay, so we have to find out like how many rooms we need at least to get all the meetings done. So we have to find the minimum number of conference rooms. So obviously you can see here, like if we had like 3 meetings and if we say like, hey, allot them 3 rooms, yeah, we can just allot them 3 rooms, right? But not always we need all 3 rooms. That's why we need to find out the minimum number of rooms. So as you can see in this example here, you see that this meeting like 5:10, this one is already done. And after this is done, this one starts, right? So that means these two meetings actually can use the same room, right? Same room, because they are not happening at the same time. You can see that, right? But this one can't happen with this, or this one can't happen with this because they're being done in the uh, same time, right? So this is another room. So we need 2 rooms for that, for these, right? We need 2 rooms. For the second example, you see there are 2 meetings and one starts at minute 2 and ends in say or second hour and ends at fourth hour, or say 2 p.m. to 4 p.m. and the other one is 7 a.m. to 10 a.m. So the times don't overlap, so they can actually use the same room, right? Okay, so how many rooms, minimum how many rooms we need? So let's think about this. Like, how can you find the minimum number of rooms? I would give you like I would ask you to think for some time to find out what's the way to find the minimum number of rooms, and then we can come back and discuss. Okay, so hopefully you have thought about it. Uh, and I think you have figured out. So the minimum number of rooms depend on what is the maximum number of overlapping meetings, right? So you can see here this is like 3 overlapping meetings, right? Okay, so that means all these 3 meetings are happening. So if I draw a line that is intersecting everything, then you can see that this line actually is going for a specific time. It actually intersects all 3 meetings, right? So this is meeting 1, this is meeting 2, and this is meeting 3. So they intersect. This line is intersecting. This is a specific time, right? At a specific time, all 3 meetings are happening. So that means we have to find out the max number of overlapping meeting. That's what we want to find out, right? Okay. So now let's think about another thing. Let's say another meeting comes in. Um, let's say another meeting comes in, okay? Now the question is like, do I need another room? Obviously, these 3 need 3 rooms, right? That's clear. But for the new one, you see here, do I need the 4th room? Okay, so before I start, let's say this, like, let's suppose we have sorted them in according to their start time, right? So this one comes first. Let's change this a bit so that it looks sorted according to the start time. Let's make this like this, okay? And like make this like this, okay? Now you see that meeting 1, meeting 2, meeting 3, and meeting 4. They're sorted according to their start time. And obviously we need 3 rooms here, but when meeting 4 starts, so this is the starting point of meeting 4, the obvious question is, do I need a 4th room or not? To ask this question, can we take a look at the meeting that has earliest ending time, right? So basically out of these 3 meetings, we want to find out the meeting that has the smallest. So my question would be like the smallest end time, right? Or smallest or earliest, right? Earliest end time is the smallest end time. So we have to find out the smallest end time. And obviously you can see the smallest end time, the meeting that ends earlier is this one, right? And as you can see, this one actually starts before this one starts, right? This one ends before this one starts, right? Then we can say, oh, okay, so the smallest or the earliest end time meeting ends before me, right? Ends before me. That means I can just use this room. So this one was, say, using room 3, right? So I can just assign this room to this meeting because that meeting has ended. Okay, so here is a very important intuition. So that means we have to, whenever we are actually looking for a new meeting, whether a new meeting needs a new room or not, we have to find the smallest or earliest end time of the existing meetings. So how can we actually get that? Yeah, so several of them are happening. Can we use a priority queue? That way we can always keep the smallest ending time at the top and then just check if the smallest ending time is less than, so this is the smallest ending time, right? Is if this is less than me, right? Less than the new start time. So we can use the priority queue, right? Or if it was like this, say the meeting 3 was looking like this. The same when meeting 4 came, right? Obviously there were 3 rooms being used already. So meeting 4 came and asked, like, do I need a new room? For that, it asked this question. What is the smallest or earliest end time? Well, obviously this is the smallest end time, right? This is the smallest end time. But the thing is, this smallest end time is greater than my new start time, say. So the end time E3 is greater than the start time S4. So now we say, yes, you need a 4th room, right? So think about this. Say meeting 3 was staying at the top, meeting 2 and meeting 1 was also in the priority queue, right? And then what I have to do is I have to add meeting 4 to the priority queue as well. Okay. So meeting 4 will be in the priority queue as well. And as you can see, the meeting 4's ending time is even far beyond. So meeting 4 will be inside the priority queue, not at the top. And you see that? So that means the size of the priority queue at any time represents the number of rooms. Okay, the size of the priority queue will represent the number of rooms. Let's change this meeting a little bit. Let's say meeting 4 was looking like this. Sorry, meeting 3 was looking like this. And meeting 4, let's say meeting 4 was looking something like this. Okay. So obviously these 3 meetings were happening in 3 rooms because they were happening at the same time. And then meeting 4 came and asked this question, hey, do I need a fourth room? So for that, it asked this question, right? This question, and the smallest or the earliest end time is obviously E3, and that is greater than E3 is greater than S4. So yes, I need a new meeting room, right? So I push meeting 4 into the priority queue as well. Now this time you see that the ending time, this is N4. This is smaller. This is the smallest ending time now, right? So what happens is once I push this, M3 goes inside the priority queue and M4 comes at the top. So when the fifth meeting comes, the fifth meeting, now it looks for the ending time of the fourth meeting because this is the smallest now, and we have this is a min heap, right? So this is a min heap. Okay. Okay. And what? Okay. Now you see meeting 5 have come, right? Meeting 5 has come, and we already see meeting 5. We will ask this question: what is the smallest or earliest end time of the existing meetings? It says E4, and E4 is smaller than S5. Do you see that? This is S5. So what we do, we just take M4 out of the queue. So we take M4 out. This was M4. We take it out. And what we put is M5. We put it in the queue room, right? Okay. So we have to have a priority queue of intervals. Each interval is actually an array of 2 elements with the start time and end time. We call it PQ. So new priority queue, and then the max size of this priority queue is going to be intervals dot length, and this priority queue is a min heap. So basically, if there is 2 meetings A and B, this priority queue is going to be determined based on the end times. So A1 minus B1. So this is going to be determined based on the end time. Okay, so that is the priority queue. Next, what we have to do is we have to sort the meetings based on their start time, right? Okay. So we are going to sort these intervals array based on their start time. We change it to 0. Okay, so now they're sorted. Okay, so next what we do is initially we have to put the first meeting into the queue. Obviously that we're going to push the first meeting, right? And then for each meeting, say current meeting from intervals. Okay, let's not do this thing first. So I am reading each meeting, and if the queue is empty, that means this is the first meeting, right? If the priority queue is empty, then what I do is I don't do it. I will just add the meeting to the priority queue, right? Or if it's not empty, let's do this. If it's not empty, pq dot topic. If the end time of the meeting, that is 1, is less than the current meeting's start time. That means this is the current meeting. If that is the case, then I just remove that meeting or release that meeting. So partyqueue.fall. I move that meeting out so that that room is now released for the current meeting. In all cases, I'm going to add the new meeting to the priority queue, right? And finally, the size of the priority queue is going to determine is going to be the number of the rooms, right? Let's check the code if there is any mistake. Okay, so here is one mistake. And here is the other one. So if the previous, like the meeting with the earliest ending time has the same starting time with the current meeting, even in that case, both of them can do in the same room, right? Because one stops at 10, other one, say, let's say one stops at 10 a.m., the other one starts at 10 a.m. So obviously one group of people can leave and the other group can start. So I'm just fixing this. Now let's run this. Okay. And then submitting. Yep. So this was also pretty fast. Now let's see what is the time complexity of this algorithm. So you see this sorting for n meeting, this is order of n log n. And this one, we have n meetings, right? And each time we are doing this thing, like either we are adding to the priority queue, right? Adding the meeting to the priority queue. Okay, so this is the order of log n operation. And so in total, this total thing is going to be order of n log n. For each of the meetings, there is order of log n operation, so n log n. So you see, finally, our time complexity is n log n plus n log n, so it's order of n log n, okay? And the space complexity, so that's the time complexity. And what is the space complexity? So we have this priority queue, right? And max size of the priority queue is n. So if all the n meetings are happening at the same time, at a certain point, then all of them go into the priority queue, right? Never polling happens since all of them are being added. So the space complexity is order of n. Okay, so that's it. Thank you very much for watching. We will come back with another problem.